Good evening, Bearcats. All right, this is 4.3 day 2, and we're going to continue with our right triangle trigonometry. One thing that I mentioned today on today's classwork, I wanted you to stop after 31, and we wanted to work some of the proofing together. You will have some of these on your test, and you really have to know them. So I'm going to work several examples, and then tomorrow in class, you're going to work 33. Write this down because I'm going to check your notes. So your classwork tomorrow will be 33, 35, 37, 39, 40, and 41. I'm going to work several examples of these types of problems. Then we're going to work tomorrow in class 43 through 47, and that's calculator. And we may just talk about that and work that together in class so I can show you how to set the mode in your calculator. And then important, I want you to work 53 through 61. And those are right off of your chart that we've memorized. So this is off the chart. Off the chart. Get it? It's off the chart. Okay. Sorry. All right. Next, tomorrow when we come in, we're going to see problems 63, 64, 65, and 66 on the board. You're going to see those numbers. And you're going to be asked as a group to go up, read a problem. I'm going to assign each group. There'll be a group number on there, underneath there. And you're going to go up together as a group, and you're going to read those problems, and you're going to set up the problem. You're going to draw the picture for us. We're all going to do that about halfway through class tomorrow and talk about those. And that'll finish up 4-3, and then tomorrow night we'll move on to 4-4. Okay, so right now, I want to go through and I want to work some examples of problems like these tomorrow. And these get to be a little tricky. You have to use your identities and you have to know your identities. So let's review those one more time. Remember I said today in class, the more you write them down, the better you're going to be. We know we have sine. We know that sine is equal to 1 over cosecant. We have cosine, which is equal to 1 over secant. We have tan, which is equal to 1 over cotan, which is also equal to sine over cosine. Very important. And then finally we have cotan, which is equal to 1 over tan, but is also equal to cosine over sine. And of course cosecant equals 1 over sine, etc. You can take the reciprocal of those first couple as well. The other thing that we really need to make sure that we are concentrating on are our Pythagorean theorems. Our Pythagorean identities. We have 3 of them. We have sine squared theta plus cosine squared theta equals 1. It's important that you understand that. Also realize you could rewrite that. You could move the cosine to the other side and have sine squared theta equals 1 minus cosine squared theta. So you could manipulate this equation, but this is really important. Remember, sine is y, cosine is x. It's kind of like x squared plus y squared equals, or a squared plus b squared equals c squared kind of thing. That's pretty basic. The next two are a little harder to remember, and I've got a funny way for you to remember. So one of them is 1 plus cosecant. I'm sorry, that is not right. Sorry, 1 plus cotan squared theta equals cosecant squared theta. And the last one is 1 plus tan squared theta equals cotan. No, equals secant. Sorry. Wow. Not talking faster than I'm thinking faster than I'm talking, or talking faster than I'm thinking right now. Sorry. 1 plus tan squared theta equals secant squared theta. All right, here's the little way I remember these. And tomorrow when you come in, I want you to draw me a picture of the 2 things that I'm talking about in here in your notes. I want to see that you drew a picture of these two things that I'm using to refer to this. So to remember these, 1 plus cotan squared theta equals cosecant, I think that about a circus. When I've been to the circus, and one of the fun treats as a kid to have at the circus was cotton candy. And I think of this as 1 plus cotton, that's the COT, squared theta equals, and I know that's not really candy, but that's another C word. 1 plus cotton candy reminded me which ones went together. For this second one, when you eat an orange, you peel it and then you tear it into sections. There's also a type of orange, or it's kind of an orange combination called a tangerine that you may have eaten, and I think of this as 1 plus tangerine sections. 1 plus tangerine sections. So 1 plus tan squared theta equals secant, or section squared theta. That's how I remember. So tomorrow, draw me a picture of cotton candy and of tangerine sections, and that'll help you remember, plus I'll know that you paid attention tonight. Also, the following examples you need to have in your notes so that you can work at the beginning of class 33 through 41 tomorrow. All right, so let's get started on that. These are the even problems that match up with that, so I'm going to work 34. This is on the same page, so you will know how it matches up. We'll be given cosine theta times secant theta equals 1. And the instructions is to use our identities to transform the left side into the right side. So basically, we cannot change or move anything onto the right side. We're going to keep this. I'm going to put a box around it, and we're not going to touch it. We're going to take this side, and we're going to change something because of what we know about identities to help us make this side transform into 1. I usually don't change my cosine, sine, and tan first. I usually change the other identities first most often. There's no hard, fast rules with this. This is sort of a trial and error, but the more practice, the more intuition you'll have about what to do. So I'm going to take cosine, and I'm going to leave my cosine theta for a minute. And because I'm multiplying, I'm going to put it over 1. So this is just rewriting this one. For secant, though, I know secant is the reciprocal of cosine. So I know secant, if you look back at what we just wrote down, secant can be 1 over cosine theta. So I'm going to put a parenthesis around that. So I rewrote this. All of a sudden, if I multiply straight across, I get cosine theta times 1, which is cosine theta. And in the bottom, 1 times cosine theta is cosine theta. And that is equivalent to 1. So now I have 1 equal 1. And that's exactly the way I want you to do it, and you'll have some like this on your test. All right, let's look at another one. Some little differences in the next one. This one's going to be 36 out of your book. It'll match up with 35 a lot. So this is cotan theta, and they use alpha. I'm just going to use theta because it's easier. Sine theta, and it equals cosine theta. All right, again, I'm going to put a box around cosine, and I'm going to look over here to change something. I'm probably not changing this one right now. I may have to in a minute, but right now I'm going to leave that one, and I'm going to try to change cotan. If you look at your identities at cotan, there is one of them that has to do with sine and cosine in it. And the cotan is equal to cosine theta over sine theta. So I just rewrote this based on the reciprocal identities, and this is in this case. Sine, I could just rewrite as sine theta, and I could put it over 1. So I just kind of copied it back down. Now, if you notice, if I multiply straight across, I would get cosine theta, sine theta. And in the bottom, I get sine theta times 1, which is sine theta. And because I'm all multiplying, I could make a cancellation. And when I do, I would end up with cosine theta, put a box around it, and that is equivalent to cosine theta. So I proved that. So we're going to say go Bearcats. Oops. All right, moving on. Let's take a look at 38, again, which will correspond much like 37. I'm not doing the ones you're supposed to do because you really have to practice these. This is brand new stuff that you have to practice. So 38, I get 1 plus sine theta times 1 minus sine theta. And that equals cosine squared theta. Okay, we get a little trick here. So I'm going to put a box around this again and not bother it, not move anything to that side. I'm going to look over here. This is like a binomial. This is almost like the difference of squares if you look at it. These are two conjugate pairs, a 1 plus a value and 1 minus the same value. This we're going to FOIL together, but remember, because these are conjugates, if you remember this from before, it's like, 1 plus x and 1 minus x, or x plus 1 and x minus 1. If you remember that, remember when we FOIL the middles will always cancel out. So we're only going to have to multiply the first times the first, which would be 1, and the last times the last because of the positive and negative. So sine theta times negative sine theta is negative sine squared theta. All right. Then this is what I need you to do. You are thinking about the Pythagorean theorem here. So tell me that you're thinking about it. You can, draw me a little happy face with a little thinking sign above it or whatever you want. And I'm going to write down the Pythagorean theorem I'm supposed to be thinking about that involves sine and cosine. So the Pythagorean theorem I know is sine squared theta plus cosine squared theta equals 1. If I move sine theta on this side, I get cosine squared theta equals 1 minus sine squared theta. And so, in fact, 1 sine squared theta is equal to cosine squared theta, which is what I was trying to prove from the beginning. Now, you may need to pause and think about that one a little bit more. That's a little bit tricky, so you may have to do that. All right, I'm going to work 42, and then I'm going to go on and I think that may be all we do tonight. I'm going to have you just make sure that you know your chart and about working on your calculator for tomorrow. So we have several things to do tomorrow. So when you come in tomorrow, the first thing I want you to do is have your notes out, because I'm going to give you a point on your next test if you have your notes ready and have done them. And the second thing I want to have you do is you're going to work that first set of problems starting with number 33, and those are going to be similar to these problems we just did, so you have an example to look at. I need you to get that done quickly so we can move on to the other things we have to accomplish tomorrow. All right. So last one I'm going to work is 42, and again we're just building up to being a little more complicated, and this will be sort of helpful with 41. They're all similar but a little different. This is tan, and they use beta. I'm going to use theta because it's easier to see, plus cotan theta over tan theta. And sometimes you can start out on a path and the path doesn't work out too well and you have to kind of readjust and start over and change your path. All right, but we're going to go and put a box around this side and not bother this, and we're going to see what we can do over here. The first thing I do is this numerator shares a denominator, so I'm going to separate it. I'm going to make it tan theta over tan theta plus cotan theta over tan theta. I'm going to have to do a little work with this one. Well, tan theta over tan theta is simply 1. All right, so that's good. I've got that done. This one, plus, I'm going to put a bracket, and I'm going to write this out a little differently. I'm going to make it cotan theta divided by tan theta. Cotan can be written as what? We're trying to get to cosecant. We're trying to get to cosecant. So if we had, this also has to do with Pythagorean, since it's got a cotan and it's got a cosecant, and that's the cotton candy thing. So I'm going to come up to the side of my paper and I'm going to think about my Pythagorean identity for just a minute. So I'm going to write down my Pythagorean, which is 1 plus cotton squared theta equals cosecant squared theta, the cotton candy one. So if I could get this information to be cotan squared, then in fact 1 plus that cotan squared would be cosecant. So let's see what I can do here. I'm going to say 1 plus, I'm going to keep this in brackets, I'm going to write cotan, I want cotan, so I'm going to leave it, I'm going to put it over 1. I'm dividing by tan, but tan is the same as 1 over cotan, so I'm going to divide by 1 over cotan theta. Now I'm going to do something else. I'm going to say 1 plus, in parentheses, I'm going to have cotan theta over 1, and I'm going to multiply by a reciprocal. That would be cotan theta over 1. We're getting somewhere. So now what am I going to do? I am going to go 1 plus cotan times cotan all over 1 would be cotan squared theta. which we now know is cosecant. So I'm going to now say, all right, so this is cosecant squared theta. And I'm just following down, so that in fact is proof that this is equivalent. All right, again, that's a lot to absorb, and you have to be really comfortable with your Pythagorean identities and your reciprocal identities. So at the beginning of your notes, you want to have those written down, and I would say I would love to see them written down 2 or 3 other times in your notes, that you keep writing them down. That will help reinforce your memory. That's it for tonight. You're going to use these examples to help you with 33 through 41, and then I'll teach you something in the calculator that's very brief. And then we'll go back and start on our application problems. And I'll have each group help with that. All right, so have a great night, and I will see you tomorrow. But practice a little bit more. And if you didn't get enough practice today in class on the first part of the assignment, please go back and finish that as well. And don't forget your notes tomorrow so you can get your point. Talk to you later. Have a good night, Bearcats.